Hi guys, and welcome to another video, and in this lesson we're going to be looking at fractional distillation. Fractional distillation is how we separate crude oil, and we use fractional distillation to separate crude oil because the hydrocarbons have different boiling points. And you can see here that we have a fractionating column, and you need to be able to explain how the fractionating column works when separating crude oil. So the first thing that takes place inside of this fractionating column is that we boil the crude oil. In other words, we turn the crude oil into a gas. Now, the light molecules, or the shorter chain alkanes, they will rise to the top of the column. And the reason they rise to the top of the column is because it's cooler at the top. Now, the shorter alkanes have a lower boiling point, and this is because they have weaker intermolecular forces. Whereas when we look at the longer alkanes, we see that they tend to fall to the bottom of the column. This is because it's much hotter at the bottom. And the reason the longer alkanes fall to the bottom is because they have a much higher boiling point. They have this higher boiling point due to stronger intermolecular forces. And then finally, when the alkane reaches its boiling point, it condenses. And this just means it turns into a liquid. Now, for your exam, you will need to know the different parts of crude oil that come out of these pipes. The different parts of crude oil that come out of these pipes are called fractions. Now, this bottom pipe here, this is where the crude oil vapor or the crude oil gas enters. Now, let's start at the top of the column where it's cooler and where the molecules are much shorter. So we start off with petroleum gas. Now, petroleum gas is used for cooking, and it's also used for heating. After petroleum gas, we have petrol. Petrol is used as a fuel for cars. After petrol, we have kerosene. Kerosene is used as an aircraft fuel. Then after kerosene, we have diesel, which is also used as a fuel for cars. And then we also have heavy fuel. Now, heavy fuel is what's used in power stations or on ships. And then finally, we have bitumen. Bitumen is used on the roads or on roofs. Now, there is a way to remember all of the different fractions just by using the first letter of each fraction. And I remember it like this: pretty penguins keep drinking hot beer. Now just remember, as we start from the top and go down this fractional column, the alkane chain is getting longer. Now you will need to know the different properties of long chain alkanes compared to short chain alkanes. A long chain alkane tends to have a higher boiling point, whereas the short chain alkanes have a lower boiling point. Long chain alkanes are less volatile, which means they're less likely to turn into a gas, whereas the short chain alkanes are more volatile. The long chain alkanes, they tend to be less runny. They don't flow as well, whereas the short chain alkanes flow easily. Finally, the long chain alkanes, they do not ignite as easily, much harder to catch on fire, whereas the short chain alkanes ignite easily. And it's these properties that make short chain alkanes much better fuels. Okay guys, thanks for tuning in. Stay in touch for another video.